So if you just have x squared minus 4 equals 0, you would add your 4 and get x squared equals 4. Then you would take the square root and get two solutions, positive 2 and negative 2. Okay? But if you were to have x squared plus 1 equals 0, you subtract that 1, x squared equals negative 1. When you were in Algebra 1, we would say that that's no real solution. Okay? So this is where you have to expand your group of numbers into the complex numbers, which are your imaginary numbers. Okay? So your imaginary number I is defined as I equals the square root of negative 1. So when you take the square root of a negative, are y'all missing something?
This was a sheet, and it's supposed to be a math sheet. Like, we only have one paper.
Does everyone only have one paper?
No, most people have. Ours was just like one sheet. Yeah.
Okay, so y'all are good now? Yes. Okay. So the square root of negative 1 would just be I. So with that, if you were to take I squared, you're basically doing the square root of negative 1 times the square root of negative 1. And you know that when you take the square root of a number times itself, it just leaves you with that number under the radical. So I squared will equal negative 1. These two are important, and that's what you'll use most of this lesson. Okay? So the square root of a negative 1 is I, and then I squared is negative 1. Okay? So 7i, negative 5i, I squared of 3, or negative I squared of 3, all of those examples are pure imaginary numbers. Okay? So for right now, if we were to solve x squared equals negative 13, you would still treat that like x squared equals 13. Take the square root of both sides. X equals plus or minus square root of negative 13. Well, you can't take the square root. Before this, you couldn't take the square root of the negative and get an actual number. So this is where we're going to take out an I, because this is essentially the same thing as the square root of negative 1 times 13. Well, the square root of negative 1 is your I. So this is where you're going to get plus or minus I. You pull out that I for the negative, then have square root of 13. Check to simplify. I can't simplify because 13 is prime. So that would be my answer. Yes? No, you can just write a normal I. I write my I's weird, so if I don't write it like that, it doesn't look like an I, because I don't dot my I's unless it's this. So, if I have x squared equals negative 81, take the square root of both sides. X equals plus or minus square root of negative 81. Well, that ends up being a perfect square, right? 81 is a perfect square. I take out the I for that negative 1. What's the square root of 81? 9. So the square root of negative 81 is plus or minus 9i. Okay, so that negative under the radical, you're just pulling that out with an I, because that's just a negative 1. Okay, then you just evaluate whatever number is left. So you're going to treat this the same way we were treating problems last lesson. 3x squared minus 7 equals negative 31. I'm going to add 7 to both sides. 3x squared equals, divide by 3, and x squared equals. So I take the square root of both sides. X equals plus or minus I squared root of 8. Can I simplify the square root of 8?
Yes.
Because 8 would split into 2 and 4. 4 splits 2 and 2. So really, that could be x equals plus or minus 2i square root of 2. You good with that? Okay. So those are your pure imaginary. So standard form of your complex takes a real part and your imaginary part and combines it. Okay? So anytime you have the full complex, this is standard form where A is your real part and this BI is your pure imaginary. I can't see that. I wrote that small. That's your imaginary part. So an example of that would be like 2 plus 3i. 2 would be the real part. 3i would be your imaginary part. Okay, so that's how I expect to see your answers. Sometimes the examples, your I will come first. Just make sure you flip-flop them to put it in standard form. So when you are adding and subtracting complex numbers, you're going to treat that I like any other variable. That's going to make it's like terms. So you can only combine imaginary with imaginary and real with real. So if I have 8 minus I plus 5 plus 4i, I'm going to have 8 minus I plus 5 plus 4. I'm going to take those out of parentheses and combine my like terms. So 8 plus 5 would give me 13 for my real part, and then negative I plus 4i gives me 3i. So 13 plus 3i would be my answer. Now, if I have 7 minus 9i minus the full 3 minus 5i, when I am subtracting, I can drop that first set of parentheses, the terms in the first set, but what am I going to do with the second set of parentheses? If I'm subtracting, I have to change the signs. So that becomes minus 3 plus 5i. Because you're actually taking a negative 1 and distributing it, if you want to see it that way. That's why you are changing the signs. So then 7 minus 3, negative 9i plus 5i. And there's your answer. Okay? So then this next example, I have 10 minus 3 plus 7i plus 4i. I need to take that minus sign and I'm distributing that negative 1. So I have 10 minus 3 minus 7i plus 4i. I've got to get rid of those parentheses before I can combine like terms. Then 10 minus 3, 7, negative 7i plus 4i. Y'all good with that? Okay, when you are multiplying, you're going to multiply. Later on, we're going to distribute. You're going to have your 7 times your negative 9, which gives you negative 63. And I times I gives me I squared. Now on that first page, we said I squared is equal to negative 1. So you're taking that negative 63 and multiplying it by negative 1, which just gives you 63. Now when you're working these problems, I'm hoping you can go straight from here to there. When you see that I squared, all you're going to be doing is changing the sign, because that is the same as negative 1, which only changes the sign. Okay? So you don't have to show me this, but this is why negative 63 I squared ends up being just a 63. Okay? Now, when you are multiplying radicals, you need to take those i's out first. Okay? That's what I want you to do. Could you just multiply square root of negative 5 times square root of negative 10 and get square root of positive 50? Yes, but we are working with your complex numbers in this lesson, so that's what I want you to do. Pull out that I. So square root of negative 5 turns into I square root of 5. and then the square root of negative 10 turns into I square root of 10. Then I'm going to multiply. I times I gives me I squared. And then square root of 5 times square root of 10 gives me square root of 50. So I know this I squared is going to turn into a negative. But I want to go ahead and simplify that 50. So 50, if I need to do my prime factorization, splits into 2 and 25 splits into 5 and 5. So I've got I squared turning into a negative. I pull out my 5, square root of 2. If you need to do negative 1 times 5 square root of 2 to see that, that's fine. But I do for sure want to see you go from I to I squared. Okay? You have any questions on that? Alright, so square root of negative 6 times square root of negative 12. I take my I out, so that turns into I square root of 6 times I square root of 12. I times I gives me I squared. And then I have square root of. Could I have simplified this before I multiplied? Yeah. It's up to you on what you want to do. Okay? We didn't for that example, so you split 72, 2 and 36. I know 36 is going to split into 6 and 6. If you can see it like that, that's fine. Okay, that's not prime factorization, but I can tell if you're doing this, what you're doing. So this turns into negative 6 square root of 2. Now, if you would have simplified square root of 12 first, you would have had I square root of 6 times 2I square root of 3. That gives you 2I squared square root of 18. Simplify your 18, that would be 3 square root of 2. So you'd have a negative 2 from here, and then 3 square root of 2. Either way, you get the negative 6 square root of 2. It's however you see that and however your brain processes that. As long as you're showing me your work, I'm good. Okay? Now this next example, we've got an imaginary 4i times my full complex number in standard form. So when you have that, you're going to distribute it just like you would anything else. So I have 4i times negative 6, and that would give me negative 24i. 4i times I would give me 4i squared. Now this 4i squared, what does that turn into? Negative 4. So I've got negative 24i minus 4. If I leave it in that, it's not standard form. So standard form for this problem would be negative 4 minus 24i. I want my real part first, then my imaginary. Are good so far? Okay. Conjugates. We did some conjugates last class. We're going to now do it, instead of with a radical, we're going to do it with your imaginary. So a plus bi and a minus bi are your conjugates. They're the exact same thing, just different signs. So what happens when you have a conjugate, you should not have to FOIL this. I know that I FOILed it to show y'all that in the notes, but the beauty of a conjugate is to know the middle term should cancel out every single time. Okay? So if I'm taking a plus bi times a minus bi, I should be able to go straight into a squared minus b squared I squared, which is going to make sense with numbers. And then you show me what this turns into once you evaluate that I squared to a negative. Okay? So you do not have to do the negative ABI, positive ABI. You don't have to do that middle part. You shouldn't have to. Okay? So with numbers, now this, they're not conjugates. They're not the same. So I'm going to FOIL that. So you have to be aware of what's a conjugate and what's not. This isn't the same but opposite sign, so I'm just going to FOIL it. So 9 times negative 4 gives me negative 36. 9 times 7i would give me 63i. Negative 2i times negative 4 would give me positive 8i. Then I would get negative 14i squared. My two middle terms, 63i plus 8i, give me 71i. Negative 14i squared turns into plus 14. And then I combine negative 36 plus 14, and I get negative 22 plus 7i. 71i. Sorry. I still want to see the full FOIL when you have to, okay? And I don't want to see you change that to a plus 14 till that next step, because I want to make sure you understand that I squared goes to that negative 1. Now when we go to that next example, now these are conjugates. If you don't recognize that and you FOIL it and you end up getting down to your final answer, that's fine. But those of you who recognize that, you should be able to take 2 times 2 and it give you 4 minus, and then just do your second, 16i squared. So that turns into 4 plus 16, which gives me 20. Y'all good with that? Y'all have any questions? Okay. Now when you're dividing, you're going to multiply the numerator and the denominator by the conjugate of that denominator. We did something like that with your radicals last lesson. Okay? You have to make sure that you get the negative out of the denominator if you end up with a negative in the denominator. And I want to make sure your answer's in standard form. Okay? So if I have 7 plus 5i divided by 1 minus 4i, I'm going to multiply top and bottom by the conjugate, which would be what? 1 plus 4i. Now when you do that, you will have to FOIL the top. So 7 times 1 would give me 7 plus 28i plus 5i plus 20i squared. And then my bottom should just give me what? 1 minus 16i squared. And then I clean it up. So I have 7 plus 33i minus 20 over 1 plus 16. Alright, because both of those I squareds change that sign to from a positive 20 to a negative 20 and negative 16 to a positive 16. 7 minus 20, not times. 7 minus 20 will give you negative 13 plus 33i over 17. Check to simplify. I cannot. There's my answer. Y'all good? Okay. So the next problem, 5 plus 2i divided by 3 minus 2i, what am I going to do? Multiply by the conjugate, 3 plus 2i. What does that numerator become? 15. Okay. And then the bottom just becomes 9 minus 4i squared. Good. Okay, and we're going to clean that up. So I've got 15 plus minus 4 over 9 plus 4. 15 minus 4 gives me 11 plus 16i over 13. Now this next example, 2 plus I over 5i. What am I going to multiply by now? Am I trying to get rid of the 5 or just the I? Just the I. All you have to multiply, when it's like this, you're just multiplying by an I because you want that to become an I squared to be able to be equal to that negative 1. So then that gives me 2i plus I squared over 5i squared. So 2i minus 1 over negative 5. So this is where you end up, 1, that numerator is not in standard form, and 2, I've got a negative in the denominator. So I'm going to go ahead and switch all the signs, getting that negative out of the denominator, and I'm going to put it in standard form all in one step. If you can't do that all in one step, get it in standard form, then get rid of that negative. Okay, but my final answer should just be what? 1 minus 2i over 5. If you needed to split it into 2, it becomes negative 1 plus 2i over negative 5, and then that gets you your 1 minus 2i over negative 5. Okay? So then this next example, 8i over 1 plus 3i, I'm back to needing a conjugate because it's a binomial in the denominator. So that's my complex number. So I'm going to multiply by and what is that going to give me? Over so then what does that give me? Yep. Now, what is wrong with that numerator? Non-standard form. So I'm going to put it in standard form, 24 plus 8i over 10. Am I done? No, I need to simplify 24, 8, and 10. What can all three of those be simplified by? 2. So it would give me y'all good? Okay. So now we're going to simplify our powers of I. So if I know that I is equal to the square root of negative 1, okay, I'm going to look at this pattern and what happens. Anything to the 0 power, including I, is equal to 1. Well, we know I to the first is just I, and we know I squared is equal to negative 1. We know all of that. So if I have I to the third, I could break that into I squared times I. Well, I squared is negative 1 times I, which gives me negative I. Okay? If you look at the pink handout that I gave you, it takes that further all the way to I to the 12th. Okay? What happens each time is I'm going in patterns of 4. Y'all see that? So when you are doing your powers of I, what we're going to do is take that exponent and divide it by 4. And we're going to look at what the remainder is. Okay? I would star that section. That's also in your notes. Whatever you need to do, memorize that pattern. Okay? We're going to divide by long division so you can see what the remainder is. And then that is going to give us what our answer should be. Okay? So if we're looking at I to the 27th power, you would take 27 and divide it by 4. 6 times 4 would give me 24, leaving me with a remainder of 3. So if my remainder is 3, that's really I to the third, which gives me negative I. Okay? So if I look back in my notes, the rule for your remainders is there in that box. I just did I to the 27th on that handout, so I'm not going to do it again. Okay? So I'm going to move on to the middle one. I'm going to take 156 and divide it by 4. 4 can go into 15 how many times? 3 gives me 12. Bring my 3 down, bring my 6 down. 4 can go into 36 9 times. So my remainder is 0. So I to the 0 power is 1. Because your pattern from this, every 4, I start repeating. Because if I look at I to the 4th, that can split into I squared and I squared. Well, I squared is negative 1. So negative 1 times negative 1 is 1. So every 4, I start repeating. So that's the rule that they've come up with. Yes, sir. If you can do it, if you can tell me remainder of whatever, then I'll be okay with that. Like if you can do that and just do R equals 0, then tell me I to the 0 power equals 1. But for now, I'm still going to do the long division. So 78 divided by 4. I can put 4 into 7 one time. So now I need to see how many times can 4 go into 38, which is 9 times. Gives me 36. So what's my remainder? 2. So I squared is equal to negative 1. These notes should be 0, 1, 2, 3. That should match what your handout says. I was copying and pasting and changing the right side but not changing the left because I was not paying attention. So, that should be 0, 1, 2, and 3 for your remainders. Y'all good with that? Any questions? Okay. So the last section is talking about how to find the absolute value of a complex number. So we're going to have this formula that you're going to have to know when you're given a quiz or a test. If I ask you to find the absolute value of that complex number, you're going to take the square root of a squared plus b squared. Because if I were to take that bi squared, I is the square root of negative 1. Well, if I square that, we know that's equal to negative 1. Well, the absolute value of any negative is a positive. So we're just going to take a squared and b squared, then take the square root. Alright? So if I have the absolute value of negative 4 plus 3i, I'm going to take the square root of negative 4 squared plus 3 squared. Well, negative 4 squared is 16. 3 squared is 9. So that gives me the square root of 25, which is just 5. Now, we don't do a plus or minus here because you're taking the absolute value. Absolute value is always going to be positive. Now, this next one, I only have my imaginary part. So that's the same as taking the absolute value of 0 minus 3i to put it in complex form, the standard form of the complex number. So then that would be the square root of 0 squared plus negative 3 squared, which is just the square root of 9, which is equal to 3. So then the absolute value of 3 minus 7i, I take the square root of 3 squared plus negative 7 squared. 9 plus 49 gives me the square root of 58. I would try to simplify that. That just splits into 2 and 29. I can't split that any further, so the square root of 58 would just be my answer. Y'all good with that? No questions? Okay. So y'all will have a quiz over that next class. So y'all have got the rest of the period to work on the worksheet. The answer key is on Google Slides, and I'll put it up here for y'all also. And you'll have a quiz next week.